Welcome back to the video series for Geog 300 WVU Spring 2021. The previous video gave a very broad overview of the statistical analysis process. The second video here highlights a couple distinctions and of different roles that statistics plays within that process. The first one, you may have noticed that you may have noticed that statistics entered that process twice. In the third step, in describing the data, then in the next to last step of testing our hypothesis. That gets to there are two different types of statistics. Descriptive statistics and inferential statistics. The main role of descriptive statistics, you have probably seen some of these in your schooling thus far. Things as simple as the mean, the median, the mode, the standard deviation. There are plenty of others that are not as commonly used, that are used to describe the data. Likewise, presenting graphs, presenting certain kinds of maps can be considered as another means of describing the data. And so they are included within the role of descriptive statistics. In both cases, whether it's numerical, whether it's visual, their role is to summarize the data. That's the key thing here. They summarize the data so that we may better understand what is going on within each individual part of our data sets. This is in contrast to inferential statistics. Inferential statistics evaluate a hypothesis. That's both where they showed up in that framework, and it's their role within the broader scope of statistics in general. There are many different statistical tests that fall into this. You may see the term test here. Testing in statistics means evaluating that hypothesis. In the example from before, it was evaluating whether or not places that had instituted a mask mandate had higher or lower or the same COVID-19 infection rate as the places without the mandates. So to see, is there a difference? Within this course, there are a couple of different frameworks for inferential statistics. We will focus on one, just to keep the course simpler. You will see the term p-value over and over again, especially once we get into kind of the middle and end of the course that focuses more on inferential statistics. For the descriptive statistics, the statistic is basically that summary. This p-value that you'll see refers to that hypothesis. It's how well the data supports that hypothesis. and we use that to use the data that we have to evaluate, do we trust our hypothesis? Are we going to act as if that hypothesis is true or if it is false? I mentioned this here mainly to highlight when you see a p-value, you know you are working within inferential statistics. That p-value is what is used to carry out that evaluation. So that is descriptive versus inferential statistics. The other distinction that we will be working with is a property of the data that we are using. A sample versus a population. In a way, I will work with this in reverse. So starting with the population. And now we'll use polls for political purposes as an illustration of samples versus populations. So a very general phrasing of what is a population is it's everything that is of interest. That thing could be a person, that thing could be a bird, that thing could be a tree. There are many things that we could be studying. It's basically any object of study based upon whatever your problem is, to revisit that process. In a political setting, to carry out that poll, we may say all likely voters. And notice I am being very particular here in setting up what the population is, because it makes a difference. If I want to say all likely voters, I want to know what do I expect the outcome of the election to be. If I am interested in every single person who is above the age of 18 and could potentially vote, that's one thing, that's one population. Not everybody who is of the appropriate age is actually registered to vote. So if I want to understand how the election is going to turn out, I might want, say, the population to be registered voters as opposed to every potential voter. So recognize that distinction in the population or the people of interest. But even then, turnout is never 100%, even among registered voters. So really, I want to try to understand the possible preferences of anybody who's likely to show up to the polls. Not just anybody who's registered, but those who will actually either send in a mail-in ballot or trek to the polling station. So my population here would be all likely voters. Now, if I am trying to understand then ahead of time, I don't have the resources to actually call every single voter in the country or the state of West Virginia. So instead, I want to have, I'm just calling a subset. That subset is the population, is the sample of the population. Now we'll see more about sampling in a few weeks. But there's one really key element here. is that the sample ought to be representative. That I can ask 100 people who were they likely to vote for president. If I ask 100 people in the state of West Virginia, that would probably tell me something around, based upon what happened in November, somewhere, I don't know, 60, 65 roughly, of those 100 people might have said they're going to vote for Donald Trump. Which, while that might be an accurate telling of the voting preferences for West Virginia, I can't use that for the entire country. Because West Virginia is not representative of the country as a whole. Likewise, if I have a sample that is mostly men or mostly women, or mostly higher income versus lower income, or mostly of one race category versus others, I could get a misleading conclusion because the demographics and other properties of the sample are not an accurate representation of those demographics of the population. So in order to make sure that the conclusions of the sample, which almost always in any study is all the data we have. We don't have the population data. We only have the sample data. And so we want to make sure, as best as we can, that our sample data is going to adequately represent and stand in for the population, because we don't have the time or the money or other resources to conduct a full census of the entire population. So that is a sample versus the population. A sample is a subset of the population that ought to be able to adequately represent the population within our analyses. Both the descriptive analysis, the descriptive statistics like the average or the mode, as well as in our inferential statistics to evaluate very precisely a hypothesis using, in the examples in this course, a p-value to come to an evaluation or a conclusion about the extent to which we believe our hypothesis excuse me, our hypothesis to be true. So that is descriptive versus inferential statistics, as well as samples versus populations. Two key statistical concepts that are important in moving forward within the course. As always, if there are questions, we have the in-class Q&A, as well as email that you can reach out to me through. So have a good one. I'll see you at the next video.